Welcome to the solution of LeetCode problem 743 named network delay time. In this problem, you are given a network of n nodes level from 1 to n, and you are also given times, a list of travel times as directed edges, where each of the element consists of u, v, and w, where u is the source node, v is the target node, and w is the time it takes for a signal to travel from source to target. Now, you will send a signal from a given node k, and you have to return the minimum time it takes for all of the n nodes to receive the signal. And if it is impossible for all of the n nodes to receive the signal, you should return -1. Now let's consider the first example. Here, this is our directed graph. There is an edge between 2 to 1, 2 to 3, and 3 to 4. And all of the weight are 1. Now here our source node is 2. So from 2, if we pass a signal in one time, or suppose in 1 minute of time, it will reach to the node 1. Again, in 1 minute of time, it will reach to the node 3. After reaching the node 3, it will take another 1 minute to reach to the node 4. So the minimum number of time it takes to reach all of the node of this signal is 2. So we have to return 2. I hope you understood the problem statement. Now let's move on to the algorithm. In this problem, to understand the algorithm, we have taken this example. Here, suppose our source node is 1, and in the 7 minute, our signal reached to the node 2, and in the 2 minute, our signal reached to the node 3. Now, from the node 3, in the 3 minute, our signal reached to the node 2. So, for this path, it will take 5 minutes minimum to reach node 2, and it will take 3 minutes to reach node 3. Now, from 3, by adding 5 minutes, in total 8 minutes, the signal reached to the node 4. So here, what is the minimum time we need? Sorry, it is not 8. Actually, from 1 to 3, it will take 2 minutes, and from 3 to 4, it will take 5 minutes. So in total, 2 plus 5, 7 minutes. So here, the minimum time it takes for the signal to reach all of the node is 7. So the question is, how can we solve this problem? The first intuition comes into our mind is that if any kind of problem, we are given some of the weights in a graph, those kind of problem basically solved using the Dijkstra algorithm. So here we will use the Dijkstra, and to implement the Dijkstra, we will use the min heap. Here we are using a distance array. Initially, all of them are initialized with int maximum value. And our source node here is 1. So now let's start the Dijkstra. Our source node is 1. So the distance will be from source node to source node is 0. And we will insert into the min heap, which is the distance and the node itself. Now, what is the top element of the min heap? It is 0 and 1. So we are at the, sorry, it is 1 and 1. So we are at the node 1. So from node 1, we can reach node 2 and node 3. So try to reach the node 2. So here we will check whether the distance of 1 plus the weight, which is 7, is less than distance of 2 or not. So here distance of 2 is infinity, which is the large value. So it is true. That means we can assign 7 in the distance of 2, and we will add the value 7 and 2 here into the min heap. Now again from 1 we can reach node 3. Again the distance of 1 will be 0 plus weight 2 is less than the distance of 3. So we will assign the value 2 here, and we will add the value 2 and the node itself, which is 3. After that, as we have processed the node 1, we will remove node 1 from the min heap. Now, what is the top element of the min heap? Which is this, and here the node is 3. That means now we will start the iteration from the node 3. So from node 3, we can reach to the node 2 and node 4. So now, first try to reach to the node 2. So here, the distance of 3 will be 2 plus the weight, which is 3, which is this weight. We should check whether it is smaller than the current distance of 2 or not. The current distance is 7. Okay, that means 5 is smaller than 7. It is true. That means to reach node 2, we should use this path. We should reach 1 to 3 and 3 to 2. And we should avoid this direct path from 1 to 2 because the weight is higher. So here we will assign the value 5 in the node 2, and we will insert the value 5 and 2 here. Now from 3 we can reach the node 4. So we have to check whether the distance of 3, which is 2, plus weight, which is 5, less than the distance of 4 or not. The distance of 4 is infinity. So yes, it is true. That means we can assign the value 2 plus 5, which is 7, into the distance of 4. Now we have processed all of the entry of the node 2. So far, what is the top element of the min heap? It is 5 and 2. So currently, our current node is 2 here, because in the min heap, the first element is the weight and the second element is the node itself. But node 2 does not have any of the children or any of the adjacency list entry. So here we will simply ignore this entry, or we will simply remove this from the heap. Now, what is the top element of the heap? It is again 7 and 2. So here the top element is 2 again. So again we will remove it. Now our heap become empty and our distance array has 0, 5, 2, 7. This means that to reach node 1 from node 1, we have distance 0. To reach 1 to 2, the distance will be 5. To reach 1 to 3, the distance will be 2. And to reach 1 to 4, the distance will be 7. So what is the minimum time we need to pass the signal from the source to all of the node? It will be the maximum of all of them. It is 7. So we have to return 7. I hope you understood how the Dijkstra algorithm basically works here. Now let's move on to the code. Here we are given a function named network delay time, which has a vector of vector and number of nodes and a source node. Now we are making an adjacency list, which is vector of pair. Now for each of the entry in the vector, we are making the adjacency list, which is we are inserting adjacency of x dot pushback y and w. So we are inserting the weight itself. Now we are declaring a min heap and taking a distance set of n plus 1 initialized to its integer maximum. Now, initially the distance of k will be 0 and we are inserting 0 and k to the min heap. Now, we are running this loop until the min heap becomes empty. And the current node will be the top elements of the min heap, second element. And we are removing it from the min heap or from the queue. Now, we have to iterate for in the adjacency list of the current element. Now here the child is iterator of first and the weight is iterator of second. Now if the distance of current element plus weight is less than distance of child, that means distance of child will be initialized with distance of current element plus weight, and we will insert distance of child and child into the min heap by making them as a pair. Now, after completing this loop, we have to initialize the variable answer with 0 and we have to iterate all of the element from 1 to n. Now, if current distance is integer max for any of the node, that means this node is unreachable. So we have to return -1. Otherwise, we have to initialize the answer will be maximum of answer and distance of I. Finally, we have to return the answer. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.